Hello and welcome to SkyTour Livestream. It's been a while, hasn't it? It's been a minute, as they say. You see the observatory behind me, all's going well out there. And I want to say hello to everybody in chat, but first I want to say hello to our fixture in SkyTour Livestream, Daryl Mason. Hey Daryl, how you doing?
Hello, Mark. I'm good, thanks. You? Hello, everybody.
I'm doing good, thanks. I'm doing good. Man, what a whirlwind trip it's been for us. We've been all the way out to New Mexico, went to Roswell. I did 2 talks in Roswell. Then I went to the Very Large Array in Socorro, and I spent time there. And then from there, I went to Phoenix again, relaxed a day, then went to Tucson to do another talk. And after going to Tucson to do a talk, I then came back to Phoenix and went out on the next morning early flight to get home. It was crazy. It was actually a whirlwind, and if they accept my offer, I'll be in South Texas next month at the Edinburgh UFO gathering out there, and that'd be pretty cool. And I've already been asked to go to Arkansas again for the Ozark Festival. That'll be up in April, though. But a lot of cool things. I did my fun toilet paper history of the Earth yesterday in Danbury, Connecticut. Here, I had literally just gotten back from going to all these other places I just mentioned, and I had to turn right around and do another talk the next morning, or not, next night, actually, the next evening in Danbury, Connecticut, which is about 45 to 50 minutes from here. And it went very well. People really enjoyed it, so I was pleased with that. Now I can say hi to everybody. I want to say hi to Michael Hedrick, who was first. How you doing, man? And Calibos is with us. Hey, Calibos, what's up? Petita is here. And that's PG, by the way. Tim F is here. Nice to see you. Francis Palmer, how are you? Good to see you. And Creeptasia's with us. Hey, man. And we will be checking things out. Farva's with us again. That's nice. Good to see you, Sean. So what we're looking at right here, okay, this is Epsilon Lyrae. It's a double-double. And this double-double star is really fascinating. It's in the constellation Lyrae, and in the box there. And this is a double star, and this is a double star. The stars go around each other, and then around each other as a double pair. Kind of cool. Really neat. Really neat. And it looks like one star here, but if we zoom way in, remember, we're a wide-angle shot, so it's hard to see such small separations. But we can do it on occasion. And right now, if you look where the telescope's pointing, it's leaning over quite a bit toward the northeast. So it's not in the best position to see that. Once it's up higher in the sky, we'll be able to. Hey there, Marco. Nice to see you. Francis Palmer has a question. Is Betelgeuse visible from where you are? Because it's not visible here in the UK. Actually, the visibility of stars depends on the time of year. And what we'll see in terms of Orion is that it will show up more toward the winter months. And as summer approaches, it's over by the sun as the sun passes through that region. Now, we're actually going around the sun, and so as we look in our night sky, you'll see that the stars of spring, for instance, are setting sooner and sooner, okay, as we look in the east or western horizon. And that's because we're moving around the sun, and they're heading toward the place where they will now then be behind the sun as seen from the Earth. So Orion is not visible right now. It'll be visible in the coming months as it gets closer to the fall and the winter.
Yeah, Betelgeuse is it's lost in the morning right now. The sunrise, before sunrise. Give it a month or two, and it should be visible before, well, during dawn, perhaps.
Yeah, just before dawn, it should be Orion would then be visible because Betelgeuse is going to be the second or third star to rise in Orion. That's big, besides the belt stars. Hey, Fantasy. Now, the Betelgeuse is actually interesting because as a star, there goes a Starlink satellite. We're doing a 1 second exposure, and that length that you see there is the right length of a trail for a satellite at Starlink's orbital altitude. So Betelgeuse is actually changing brightness because it's a known variable star. It's known to be. And so that said, it's anyone's guess when it's going to go supernova. It's already in its second red supergiant phase. All stars go through a double phase where they go into a red giant as soon as they run out of hydrogen, and then they start fusing helium into carbon if they're massive enough. And when that runs out, they go into a second supergiant phase, and that's known as the asymptotic giant branch. And Betelgeuse is already there, and so its end state looks like it's going to be a massive supernova. All right.
There was a recent scientific paper about Betelgeuse saying that they think it's in maybe sooner than we thought. Dr. Becky on YouTube talks about it also, that we really get to see it in our lifetimes.
I'm looking forward to that.
Yeah.
Hello, Adrian Thobin. How are you? Nice to see you. And Adrian is in Barkhamsted, which is about 37 minutes from me right now. We are in Terryville, Connecticut, Adrian, running a telescope out in Arizona. And very important thing, Francis says, probably already gone supernova would be. Yes, that's true. It would have already gone supernova for us to see it within our lifetimes. All right, Calabo says, I may be moving to the rocket side soon. Most of Starlink is moving to Texas, and I chose to remain here in California. All right. Very good. Hope you're doing well, Calabos, actually. All right. So, the double-double then here is, I just wanted to bring it up. I use it as a focus target, so I focused already. And this is our night vision mode, as we call it. And if we were to live stack this, we can actually I'll do a 10-second shot of this, and we'll live stack it. Get rid of our mode here. Clear this. Those are some of my calibration shots from earlier. And there's our double-double. And that red correction has to be done. There we go. Look at that. Now you'll see that line right there. No, that's not a nebula. There's a bright star out of view.
Vega.
You got it. It's Vega. And so we don't have the ability to get rid of stellar interference like that, but we can use it to our advantage. So there, we're gonna save this too, because that's actually kind of cool. We're gonna do a few captures of this, and it's called Epsilon Lyrae. That's the double in Lyrae. And if you're wondering where it is, let's bring up our planetarium, and I'll show you. Let's go here, and there it is. So there's Vega, and if you look at our image here, this rectangular size corresponds to this rectangular image right here. This is the size of our image, okay? So coming back to our thing here, you see that it's sort of on an angle. If that's because the telescope's flipped way over. So you basically turn your head to a line, and you can see that down at the lower right, you're going to see some reflections from Vega coming in. And sure enough, we do. When we look here, there they are to the lower right, as expected. So we'll see them. Hello, Hunter. My son just got home from the TV station where he works. All right, and so Vega is making a pronounced impact on us because it's only 26 light years away and it's bright. I want to say hi to Bonnie on Ahata 77. She's here. Cosmic Ray is here. Yeah. Cosmic Ray says, need the East Coast scope to see the double of the double. Actually, we won't actually, Ray. What we're doing is this camera we're using.
Oh.
What? What happened? You there? Daryl? Okay, I don't know what happened. Anyway, Ray says we need the East Coast scope in order to... we need the East Coast scope to see the double of the double. That's actually not true. I'll tell you why. Because we're actually replacing the camera that we're using here in this scope. And it's going to be a scope with much smaller pixels. And that means we're going to be able to... That is to say, the camera is going to be smaller pixels. Daryl has been lost briefly. When he comes back, we will reconnect. So anyway, with the smaller pixel camera, we'll be able to see a lot of details. In fact, the resolution of the smaller camera for our scope is going to be just about 0.9 arc seconds, which is quite nice. And that'll be cool. All right, so we've got 20 taken here. This is, I think, pretty good for now. And we'll actually save it. So we save it in a FITS format that you see up here. And that's our astronomical file format. That's the raw file that we have. And then what we do is we will save it exactly as seen. So you have it just like this. And if I just do some adjustments and a color correction, I'm going to save that one exactly as seen too. All right. All right. Very nice. Very, very nice. Okay. I assume Daryl's rebooting his computer, so I will wait on that. Very good. All right. So now, that's our double-double. And it's going to be up on the server under Epsilon Lyrae, EPS Lyra, or Lyra. All right, so we will get rid of that now and move on to another object. Okay, so we'll get rid of our stack. We don't need it. We're going to go back to our 1 second shot, which we call our night vision mode. Boom, like that. And it actually does look like night vision. In fact, it kind of is night vision in a sense because our camera is so dang good. All right, so now moving forward here, what I'm going to do is go back to our planetarium view right here. And we're going to take up another object here in Lyra. And it's down at the bottom here. Alright. There it is. It's a planetary nebula. It's really quite small. But we're going to try and do something with it. Right? This is called the Ring Nebula. And we're going to move the telescope now. You'll see the stars make a little streaky motion here. There they go. And there's the Ring Nebula. People are saying they can't hear me. I'm actually broadcasting, so make sure you say whether you can hear me, guys. I'm certainly broadcasting out. Audio says went way down. Okay, well, let's try bringing the audio way up. How about that? Is this better? That's kind of weird. Okay. My audio should be higher now. Okay, good. All right, so I am going to do a adjustment here. Pull this in just like that. Now we're going to zoom in on this just a little bit, just to kind of show you a couple things. Here's the Ring Nebula. If you notice, it's this looks like a smoke ring, doesn't it? Well, that's because it is the remnant of a star that has died, and that star that has died has puffed off its outer layers, and the star went through that second red giant phase that we talked about, and in that second red giant phase, it started to pulsate and slough off outer layers as it did so, out and outward and outward. And as it did that, we ended up getting a set of concentric shells that came off of the nebula, of the object here. And that's what you see there, right? So you'll notice there is a star in the center of this, and it comes and goes with our resolution here, because we're getting moment-to-moment resolution through the roof. Temperature out in the building right now is 36 Celsius, so we're in the 90s out there. All right, so we're going to try to take an image here, and for this you don't need a whole lot. We're going to just say 5 seconds, and we're going to drop the gain because that's the sensitivity of our sensor. All right, and we won't need that. Hello, Cindy Murphy. Hello, Alice Pooper. Hello, JCO. How are you, man? Thank you for coming on out. Good to see you, and it shall be a lot of fun. All right. Okay. All right, so what we're going to do is go into our stack now. We're going to do these 5-second shots at go down to 100 gain. It's still going to be really bright, but we'll see it. Live stack now. Cut out this. Clear the last one, which is Epsilon Lyrae. And then we get our Ring Nebula. You'll notice the colors in the Ring Nebula. Absolutely amazing. The colors of the Ring Nebula are based on in fact, I'm gonna clear this because our star lock system, the guide system is gotta do better. There we go. There's that central star. You can see it right in there. And the first frame is always the worst. When you see the second frame come in like you did here, and then the third, this noise in the background goes away little by little. Okay, there's the star. You can see it right there. What is that star we're seeing in there? That is the stellar remnant. It's the remains of that previous star that made this nebula. Okay, and let's go to our full sensor native resolution. All right, there's it. That's 100 now. Move it up. And let's color correct. Just give us a little bit of a better... That's the wrong color correction. That's the right color correction. All right, and we're going to bring it like this, and I'll drop the blue a little bit. That's better. Now let's try to look inside this nebula. All right. So as you can see, it turns out 5 seconds is even still too long to do this. Hi, Judy M. Hello, Alicia. Alicia Vieras is with us. I know, Darlene. Hello. Darlene is with us. She is Alicia Vieras' daughter. And Alicia bought a book for Darlene that we wrote called The Populated Universe. And I'm glad that she did, because every little child, every person has right to access science. That's all we're doing. She says hi back. How cute. Darlene came into our booth when we were at Roswell, and she sat down with us in our booth for a little while. It was fun. It was fun. Very smart kid. Cosmic Ray says there's a naked eye sunspot on the sun. That's correct, there is. And it's actually really large. It's a fraction of the size of the Carrington event sunspot, but it's still pretty big. You know? So, okay, so as you can see, there's some stars here in Lyrae that are all in our galaxy. This star here is in our galaxy, the remains. Now that remnant star in the middle here, that's called a white dwarf. And it's hard to see right here, but it's there, and it'll pop into view. I'm actually going to go to 150% on this, so we can get a little closer. First things first, let's talk about the colors. Okay, you see it has this outer reddish color here, and then this inner color that looks green, and then you see how it's almost like a hollow inside, right? That's interesting, because the way it works is like this, and I'm gonna enlarge over here. Here I go. Whoa. All right. So the way it works is like this. It's releasing this sphere of matter off the star. Now there's some controversy thinking that maybe we're looking down the barrel of a planetary nebula here, but here's effectively how these spherical things work. Okay, when a star blows off its outer layers like this, all right, the star, all right, if you look, you can't see through my fingers. That's the edges of the nebula where it's thickest and where you actually see this dense material, right? But around the front and the back, you can see through my fingers. See, there's my eye. Hello. Okay? And because you can see through my fingers, it means that the stuff is thinner when you're seeing it front to back like this. And so you can always see through the center of a planetary nebula for this reason. All right? So I think they're going to find that the Ring Nebula is probably not this deep barrel that they think it is. I think they're going to find that it really is a spherical nebula, and that's my feeling. I don't think it's a barrel. I think that research is not correct. But that's just me. That's just me. I just don't. It doesn't make any sense to be that. Okay, so the green colors, yes. Francis, I think, said it's the oxygen giving it that. Yes, a doubly ionized oxygen actually. So 2 electrons zipped off the oxygen atom and left the atom to absorb energy, and they left the atom. Now, what's that energy they're absorbing? They have to absorb it from somewhere. And the thing that the star in the center is doing is it's full of ultraviolet energy. White dwarfs are very, very hot, upwards of 45 1,000 Kelvin, okay, which is a lot higher in Fahrenheit and Celsius, a little bit. So that said, the issue that we have here is that as those electrons absorb some of this ultraviolet, they go into higher orbital shells around the atom, and eventually they could leave the atom for a time. So they've got all this energy out there, and they're moving around, they're colliding with each other, they're hitting things, and so they lose energy and then drop back into the atom. Because they're negatively charged, the center of the atom is positively charged, and so they attract. But the ultraviolet energy can overcome that for a period of time. And then when the electrons rejoin, they give off energy and they cascade down into the atom. And as they cascade down into the atom, you see that in the form of light. They give off light. Hydrogen is well known. This hydrogen on the outside here is well known for giving off a red color as the hydrogen atom's electron bounces back into the atom. That's actually called recombination. And when that happens, we see that. Right now, when we look at the green, you're seeing the result of two electrons that are bounding back into the atom and cascading down energy levels. And they go specific levels. They don't go smoothly into an atom. And the reason has to do with the discrete amounts of energy at each shell level that electrons can be in. All right, and that's why it's called quantum mechanics when we study atoms, because each energy level is a specific energy level of a specific energy. So they're discrete. You can't have a energy level, and then 0.12. Okay, it's going to be an energy level of whatever that number is. Okay, and you can't have one that's plus or minus. It's going to be an exact value. So I know that's a long, drawn out explanation, but that is kind of cool. That's how it works. So that's what the green color is from. That's what the red color is from, and the shape is due to this effect I told you about before. You're seeing through more stuff on the edges than you are at the front and the back, and therefore you can see through it. See? So that's kind of how planetaries work. Remember, this is all 3D. You're seeing the universe in 3 dimensions, and that's kind of cool. Now, it's not bad for the ring nebula that we're seeing here, because the ring nebula being as far as it is and so forth, they tend to be planetaries, to answer Anthony DeSanto's question. Planetary nebulas in general tend to be 1, maybe 2 light years in diameter when we get to see them like this. And so, but they're notoriously hard to find a distance to, and why is that? Well, I have to tell you, because when a white dwarf is ionizing gas, it can ionize it out to a certain radius, and we know white dwarfs very well. White dwarfs follow some standard behaviors that we understand. So they will ionize that gas and make that gas green out to a certain distance. Now, if the oxygen actually has gone further out beyond and we don't know it, then this nebula is at its logical diameter that it'll reach and not get any bigger, because the distance out from the star only goes a certain amount before that ionization doesn't work anymore. Okay, it's not hot enough to ionize the atoms anymore and make those electrons jump off and then drop back in and give off light. So, but what if this nebula is still expanding? Well, then we're done, because we don't know whether we're seeing the full diameter of this nebula, where all of the gas is ionized that's around it, or whether we're seeing it in progress. And because we know how far away from a star light has to be ionized, the gas has to be ionized, because we know that, we can then say, well, okay, then based on this being a light year in diameter or 2 light years in diameter, if it's at its full extent, we know it's X number of 1,000 light years away. Okay, well, we don't know that, because we don't know how far away from the star the gas has traveled, and we don't know if all the gas has been ionized yet. So we would have to do more studies to look for gas around the nebula that actually is neutral and not ionized. And so until we can do until we can do those types of studies and get that kind of data, which we can, we're not going to know how big the planetary nebula is overall. Or I'm sorry, its distance, because we can't figure out the diameter and say that's as big as it's ever going to get. Now, the biggest one that we have seen is the Helix Nebula. That one we can't watch right now, but it really is a beautiful one. And hello, Mr. Django from Belgium. How are you? Calabos has to go. All right. He says SpaceX is launching. Calabos works at SpaceX. SpaceX is launching the last of the V1.5 satellites tonight, and we're meeting to watch it. Oh yeah, excellent. Let us know how it goes. All right. Yeah. All right. So we've got a number of these that we have done, and we're gonna save them right now. First things first. I'm gonna change the name. This is called Messier 57. Messier 57 is the Ring Nebula, for obvious reasons. Okay. Hello, Simon Thompson. Okay, now I can save it. The next telescope that we're getting, I went to Star Arizona. That's another thing I did when I was out there. And I went and I designed the next telescope system with them, and I've got all the write-ups and everything. I'm going to change it on them a little bit because there's more that I want to do that I haven't done. But we'll do it. All right. Just to answer your questions, wondering what happened to Daryl. Daryl, I think he had a problem with his computer, and I could hear him. He's like, he went, "Uh-oh, what's going on?" or something like that, and then his call dropped. So I don't know what happened to him. I could try to call him again and see if he's around, but I'm not sure. But we'll try. Yeah, his it's not ringing, so yes, he says he's not online. That means that his computer probably did that great that great passing unto the great beyond for tonight, hopefully. Mr. Django says he's a little bit sad because last week's very cloudy and rainy. Yeah, I know what that's like. No, Daryl didn't turn into a pumpkin there, Mike. He actually probably turned into an angry, stomping guy who was mad because his computer crapped out or something. All right, let's just go back to our... There, see, that's this is almost the full size of our screen. This is 2 degrees across by 1.5 degrees tall. That's 4 full moons across and 3 full moons tall. That's a pretty big screen. That's a pretty big screen. I want to let everybody know I appreciate the little emojis that you're sending up there. I think that's kind of nice. Yeah. Okay. Great. All right. So what we're gonna do? We did this. I will save it exactly as seen one more time, and then save the FITS file one more time. Okay, and now we'll say goodnight to the Ring Nebula. We'll go over here and go back to our night vision mode here, and you'll see the little ring right there in the middle. See it? Right there. These little things just sit right out there, and it's pretty cool. pretty amazing how this works. Okay, now let's get our computer back up there. There it is. And what we're going to do now is go look for something else. Now, this stuff is just rising, so we have the Cygnus star cloud here. That's coming up. And I don't think we can image this yet. And Cosmic Ray knows I would like to. I'm going to try this. I don't know whether we can do it or not. It may or may not work, but we'll try it. This is called Sadr. It's the star that is the middle of the Northern Cross. Cygnus the Swan as we back out. Here is the swan right here. And if we just show you the mythology, you can see the swan's head, Alberio. This is Sadr. This is Deneb, which means the back end. And we have the two wing stars out here. Okay. And within Cygnus, we have the summer Milky Way going through just beautifully. And so we're gonna see if we can go to Sadr right now and hang out at Sadr for a little while. Okay. Off we go. Now you watch the telescope. If it interferes with the edge of the building, we may not be able to do it. Oh, I don't know. We might have lucked out, guys. Alicia says, how often do the star maps need to be updated, or are they pretty true over time? It's not a dumb question in any way, shape, or form, Alicia. No way. It's actually a very good question. The star maps themselves do vary, and they're done in what are called epochs. And there was a 1950 epoch, a 2000 epoch. So they're updated every so often because stars do move in the sky and their positions change. And we tend to do them like every 50 years or so. And this is what this was. So that's pretty cool. All right. This is Sadr right here. And it may have a slight interference with the edge of the observatory, but we're going to try it. So here's what we're going to do. We're going to... because I know what this looks like, I'm going to move us a little bit to the east. Okay. You'll notice something red looking here. Yeah, that's really cool. This is really cool. All right, so right now up there you'll see that we're searching for our guide star. We'll have our guide star in a moment, and I'm not sure if the guiding telescope can see out of the building right now. I think it's going to be close, but we'll give it a shot. Okay, it's guiding. It found the guide star. Yay. So let's do a 30-second shot here. Okay, and it says searching again, so it's probably coming and going. We're going to give it a shot though. All right, let's just do it. All right, we're on our way, so let's get out of night vision mode, go into our stack mode, and get rid of the ring nebula from last time. We'll clear the buffer. And now you're going to get to see the Cygnus Gamma Cygni Nebula, which is at the center. Sadr, S-A-D-R, that's the name of the star, is Gamma Cygni. And here comes our first view of it for the season. Ah, look at that. What a beautiful nebula. Holy cow. All right, so we're going to do that. Look at that. Ah, how beautiful. We'll color correct a little bit. And now I'm gonna pull over this side and pull this end in here to kind of punch up some of that red. Color correct again. Look at all that red. Know what that is? That's all hydrogen gas, guys, that has been ionized. Okay, look at all the red. That's incredible. It is stunning. And in fact, there's so much more over here by me. So I'm gonna go do this again. I'm gonna move Sadr up here so you can see the whole nebula. Okay, don't worry, it'll come back. So I'm gonna clear this now. I'm actually gonna just quit this and go back to our 1 second shot. And now when I do that, you'll probably say, oh, I think I see the nebula now. So see, you can see a little bit of the nebula here. Okay, I'm only at 100 gain, so I'm going to actually go up to 250. And you'll see many more stars appear. Look at that. Okay, and you'll see more nebula now. All right, so now we're going to move to the east. This is very bright nebula up here. We're going to swing to the east. Okay. Nice. This is nicey nice. Okay, go a little more. Yes, Francis Palmer says very diffuse. It is, but I did a mosaic last year, and the mosaic literally went from the whole area and encompassed the entire area all around this center area, and it's gorgeous. Now, you haven't seen anything yet, so what we're going to do now is do this again, but now it's going to be a 250 gain. And just let me, while we're waiting for our Starlock guiding star to stabilize, let me just point something out to you. Okay, this is our camera view over here. This is our telescope camera view. That up there, this is our telescope control system. This is our telescope computer. These are the telescopes in the building. You can see them here too, right there. And this, of course, is the main view. But over here on the right, the most important entries to look at are this one, the exposure, okay, and this one, the gain, right? Exposure and gain are the two most important, all right? So we pick an exposure, the time that the sensor is exposed in seconds, milliseconds actually. There's 1,000 milliseconds in a second, okay? Hence the milli, okay, 1,000 millimeters in a meter, that kind of thing. And the gain is how sensitive the sensor is during that time. So the more sensitive you choose, the more noisy it gets. And 250 is a really good number, all right? So so we should be calibrated now. Went to all our zeros, and now we're doing it. Great. So let's go and do another 30-second shot. And you're going to see quite a lot more of nebulous detail here than in this last shot. Okay, so here we go. We're going to go back to our live stack, and you'll see the previous shot. Okay, you like that, right? Well, wait till you see the next one. So we'll clear that, because we have an even better one coming. Even better. Spock, it's much, much better. I know, because I'm the captain. So here we go. Coming up, just a couple seconds now, and boom. Watch this now. We're going to process. Look at the difference. Holy cow. And we'll color correct it. All right. That looks really pretty. That looks really pretty. That's nice. Now, this is only one frame that's stacked. We're going to stack more. Now, when I say stack, we take a frame, and then we take a second frame, align it with the first, and stack it on top. Make an image sandwich. What's that do? It removes the noise. Watch how this gets better all of a sudden. Ready? Look at that. Now you see all this dark nebula in here. Isn't this amazing? And you know what I'm going to do? I'm going to take away this, and I'm going to take away our stack, and so you can just see the full screen here. I think this will be neat. There we go. Look, there it is. This is the Gamma Cygni Nebula. This star here is the center of the Northern Cross, and this Gamma Cygni Nebula is powered by this star and others around it. It is just stunning. Absolutely beautiful. Okay, so we'll let that come in now. We'll let that do a few things. By the way, guys, if you get a chance, visit our Etsy store, will you? We've got some beautiful stuff up there, gear and swag, from mugs to blankets to lamps, all with our pictures on them. So check it out. Support us if you will. We've got, we've got a lot of bills, and we are we're trying to bring astronomy outreach to the world. It's been quite a uphill battle, but I'm not gonna relent because I know that it's worth it. I believe science is for everybody. Isn't that beautiful, Cindy? Cindy goes, wow. Yeah, I agree. Creeptasia says, so mysterious, dark and red. Nice area of the sky. Oh, you know what, Creeptasia? It's just the beginning. Wait until the Lagoon Nebula and some of the other nebulae down in Sagittarius are high enough for us to look at. There actually are now if we were, without a building. But with the building, we have to, it constrains us to look once they're up above a certain amount above the horizon. And that's good because otherwise you're tempted to look at them all the time. And until they get up about 40 degrees in the, up in the sky elevation, they don't look good. So in this sense, they will look good from that. All right, so we have stacked right here 7 images. So we've made a stack of 7 images, and you'll notice that they're looking better and better. You're starting to see more detail in here. And I'm going to do something now that's going to actually make you go crazy. I'm actually going to enhance the detail in one shot. Ready? Watch this. Boom. Look at that. Holy cow. I know you probably didn't catch it. I added a certain mask which shows you all this additional detail in here. Look at that stuff. Really stunning. Oh, Cindy Murphy, I have to tell you, thank you for visiting our store and getting what you did. I think you actually bought one of our Christmas tree cluster and cone nebula blankets. That was a 60-inch blanket. That's cool. I saw it in real life. I mean, because we buy all the things that we're going to sell. And, man, those are really cool. They're really nice. They're actually comfy, too. They're that nice material like they just curl up in. I'm not a real salesman, guys, so pardon me for saying those things. But it really is just neat stuff. And it helps support us, and you get something out of it. For a $25 donation, you can also get a SkyTourLive.org t-shirt that you can't get any other way right now. So if you want that, you can do that. And we do Zelle and PayPal and stuff like that. And I would get you all that information if you wanted to. I'm going to put it on the website. Okay, we've got 10 stacked now. Look at this. All right, now what I'm going to do is I'm going to go back to our histogram where we have our curves. And I'm going to bring this one in. All right, look at that. And then I'm going to bring this one this way. This is the dark level, so we're going to actually enhance the dark. See that? All right. Now, watch. I'm going to now increase this brightness way beyond what it should be just to show you what else is hiding in the background. Ready? Watch this. Look at what else is hiding out here, waiting for us to pull it out. And we'll get it. We'll get to it. Isn't that cool? So this, again, is the Gamma Cygni Nebula, and it is just a beautiful, beautiful location. And I really would like to show you more in the constellation of Cygnus, and I will. And this will be accomplished in the next, I guess, few days. There's Gamma Cygni Nebula right there. Okay, we'll put it down here a little bit. Alicia says, my mom brag, Alicia's mom brag, is that Darlene cashed her piggy bank to make a donation. Actually, she did. And, you know what? I got to tell you guys, when you see a 9-year-old child decide that they're going to dig into their piggy bank to make a donation to you, I almost didn't want her to. I didn't want her to. I don't want to take a 9-year-old's money. That's not right. But she wanted to do it, and her mother wouldn't let me say no, because I actually said something to Alicia when she was there. I was like, you don't have to give us all the money. And she's like, this is Darlene's money. She wants to do it. Okay. Well, Darlene, you know what? It's going to a wonderful cause. It's going to help bring the world of the universe to you and other people. And you can say you had a part in that. And I'm proud of you for that. Very proud of you. It was nice to meet your dad, Donovan, and it was very nice to, of course, meet Alicia. They came as a family to see us talk and see me talk, and they hung out while we did a SkyTour live stream event at Roswell. It was really cool. Okay, Michael has a question. Could you get some STLS solar glasses before upcoming solar eclipse? Oh, I'm working on that. The solar eclipse is an annular eclipse coming up next month, and October rather, and they're talking about having me come back out to Roswell to head a nice little eclipse expedition / talk, and that's something I can certainly do and have done in the past. So I'd love to do that. Hopefully they can get this all together and do it, because it's really a great idea. It's an annular eclipse though, so the moon is a little smaller than the sun's diameter, because it's not perfect. We're not perfect. Look at this. I'm just going crazy here. This is nice. Wow. Yeah, October. Yep. The Roswell SkyTour was a private event that was actually streamed only to the local community, and that wasn't because that's their demands or whatever. That was only because I couldn't get the bandwidth to do a full-blown stream. And the reason for that was because there was one Wi-Fi available, and I had to use Wi-Fi. I couldn't use a Ethernet. I wanted an Ethernet, but they couldn't get it. And what that meant was that I only had I had to either choose between doing a stream or doing a private presentation for the people that were there. So I chose to do the private presentation because they were there. They took the time to come. They were going to get something for their attendance. So I didn't stream it to the world that night for this reason. But I did do it in Palm Springs the month earlier, and that went great. And then I'm planning on doing it again for future events. Look at this. Holy cow. Oh. Okay, I'm going to bring back my my menus here. So I put this back in the bottom, and I want to show the telescope again. So let's move this over, get our telescope back. There we go. So I can see what's happening. Oh, isn't this pretty? It is just something. And we're going to save this, of course. So I'm going to write this up here, and it will show up on the server as the Gamma Cygni Nebula. So I'll do that now. Gamma Cygni. That didn't come out right. Gamma Cygni Nebula. All right, this is 23 stacked. This is quite good. So we'll save those now. Oh, that's crazy good. All right, and then we'll save it exactly as seen. Cosmic Ray says the astronomy picture of the day has much less red. Well, I guess that's a matter of process. I mean, I can actually make it black and white. So this is approximately what it would look like if we did it in black and white. And I guess I could use a slight bit of red in there if I wanted to. So like that. Or like this. So that's good. Cindy Murphy says, I'm awestruck. Oh, well, you know what? You have no idea. You actually probably do, Cindy. When I first started doing this and saw things that I have just wished I could see all my life and saw them right in front of me, it was a mind-blowing moment. And that moment of discovery is what prompted me to keep doing this. You know, I just couldn't believe it, you know. All right. Okay, so we've got 26 here. I'm going to save it now again. If I forgot to save it, that's good. Save exactly as seen. All right. This is now going to be up on our server with all the details. So, oof. I can't tell you how beautiful that is. Just really stunning. So let's go back to our night vision mode. And you say, well, how much can you see? Well, that's what it looks like in night vision mode. All right, and that's at the gain of 250 over here, so that's pretty high. Oh, Cindy says that I explained things well. That's nice, Cindy. Thank you. Okay. Okay, we're out of the Gamma Cygni, and let's go see if we can. Oh, I know what we can do. Oh, you'll like this. We're going to go from the Gamma Cygni Nebula to something called the Crescent Nebula. The Crescent Nebula is a very different thing from the Ring Nebula we saw and from this diffuse nebula that we are seeing now and that we've just left. The Ring Nebula is a planetary nebula. The Gamma Cygni Nebula is a diffuse cloud of hydrogen that's being ionized by the hot star. This right here is another nebula that's being excited by that star right there. What is that star? That star is called a Wolf-Rayet star. These are stars that are on their way to being supernovae, and every now and then you'll see a satellite pass through. Yes. Okay, so let's move just a little bit west, center it up, and we'll wait the obligatory 14 seconds or so to get our guide star. The Sandman got Darlene. She fell asleep. Oh, that's all right. Can you imagine her dreams? She's probably going to be dreaming of flying amongst the stars. And you're welcome. So you have a good night, Alicia. My best to you and Darlene and Donovan. Okay, so now let's check this out and show you now that we're guiding. You're going to love this. This thing. We're going to do this as another 30-second shot at 250 gain. You're going to be good at this before we're done, you guys. Okay, so it's off and running, and now you'll see what we're going to get. First things first, our last object that we saw is the Gamma Cygni Nebula. It's up on the server, so we're going to clear that now. Okay. And now we're going to go to the Crescent Nebula. Okay. Notice all the stars. Look at that. That's just beautiful. This is a Wolf-Rayet star here, and it has literally blown off most of its outer layers, and it hasn't gone supernova, which is interesting. But it's going to. This is a supernova in waiting. Watch how much better it gets now. Ready? In this one shot. Watch this now. Boom. Now the detail is actually starting to come out really clearly. We can do a little bit of a process now. Yeah, there we go. And let's color correct as well. There's a lot of red nebula in here. See it? So this area of Cygnus, the swan, is just full of red nebula. Some of it is related to, of course, the Gamma Cygni Nebula and other nebulae nearby. And Ray has put up information about the Crescent Nebula, NGC 6888. It is emitting light, which is why we see it. And however, it is a Wolf-Rayet star that's lighting it up. And if we zoom in, you can see some details in this. Look at that. Look at all these details. Now, the reason why it looks so detailed and all kinds of convolutions and filaments, a very important reason, because it's not empty out in space. Okay, there's dust and gas. And when other dust and gas is blown off of a star and it comes out into interstellar medium, it collides with it. And that causes it to glow sometimes. And it also causes it to change direction, be compressed, go in one direction more than another. A famous example of that is another Wolf-Rayet star nebula called the Bubble Nebula. You know, JSCO 77 says it looks like a giant fire opal to me. Kind of does, doesn't it? Kind of does. Really cool. But again, this is the Crescent Nebula, and it is a Wolf-Rayet star object. And let's throw that out there. Right there. Let's add a little enhancement here to the colors. Isn't it crazy how now there's so many stars that it actually makes it hard to read our words? I could make solid backgrounds like on these, but those are annoying. Look at that, huh? Look how beautiful the crescent looks tonight. This is stunning. And it's actually kind of low. It's not even high in the sky. Look at the telescope. It's kind of leaning off in that direction. Leaning, leaning, leaning. Yes, the observatory spider, our obligatory black widow in our observatory has decided to move on. Adrienne Tobin says, yeah, this is then a three-dimensional blob. Yes, it is. It probably goes in like this and out like that, and you're only seeing it projected flat on the universe. But perhaps like this part here is coming toward us, maybe, and maybe this part here is on the other side of it, so it's sort of like a gigantic blob, and it might be distorted like this. It's not complete because there might be more material that's being pushed against on this side and on this side. So there could be a million reasons why it looks that way. But this is really pretty. Yeah, look at that. All right, let's see if we can do a little processing now to enhance it a little. How nice. We're going to do this. Okay, we'll come back over here, get to our curves. There we go. Let's see about darkening up our space behind and bringing out detail that's in the red. Okay, so it's a little darker. Look at that. Now you can see all this detail in there. Isn't that beautiful, guys? Wow. I don't know that we've ever seen the crescent better. I mean, if we have, I don't remember it. Holy cow, this looks really good. Adrian says, trying to get work done on my desk. Not happening. As Ray says, this nebula was discovered by William Herschel. You can see so much detail in here. There's a lot of stars. Now, most of those stars you see are in front of or behind the nebula. The only one you care about is this one right in here. This one right here that you see, that's the star that is the source of all the activity in here. Okay, so this star right here, that guy's the source. And of course, it's spread out like this all the way around, but it looks like it goes like here, but it might go further. All right, but we actually don't know a whole lot about Wolf-Rayet stars, as much as we'd like to, I should say. Yeah. And Ray is adding more detail about the Wolf-Rayet stars and how they operate. There's many different kinds of Wolf-Rayet stars we've identified. But, some blow off their hydrogen gas, outer layers. This one looks like it's done that because you see this distinctive reddish hue, but you can also see some green. So clearly there's some oxygen that actually was blown off as well. This was not a supernova explosion. That's how it's going to end its life. These stars, for some inexplicable reason, do the same kinds of things that planetary nebulae do, but at different times in their evolution than planetary nebulae. Planetary nebulae occur at the end of their lives. This star made this nebula kind of along the way during its life, which is really strange. Hey, Marianne. Daryl got dumped on us. I don't know what happened, and so I don't even see him in the chat. So I think that when I tried to connect to him, unfortunately, he shows he's offline. So I think his computer actually bit the dust. He basically could not connect. Said he's offline. But this is beautiful. The Crescent Nebula, it's a Wolf-Rayet star location. We've stacked 18. We'll go to 20, and then we'll go to the next object. See, on a night like this, guys, I get infected with this virus, and the virus is I gotta see more. But as soon as I get tired, that's when I'll probably stop. And Marianne is saying hello to everybody. Marianne, by the way, for all of you, she actually runs UAPPD, which is Unknown Anomalous Phenomena as Seen by the Police. And so she is undertaking that new direction, and they're getting a lot of good press and responses from the people that they've done their talks to. Dave Rich is her partner in crime when it comes to this, and he's an amazing good guy and a good friend. And then she's also the treasurer of SkyTour Livestream, the nonprofit organization. This is beautiful. Creeptasia, it does look like a green opal. You're right. It does indeed look like that. Yeah, I wanted to mention that Darrow's been very generous with us as well, giving him his time and more, which is really nice. And so I do want to give him a shout out for that. He doesn't want any shout outs. He's very, not in need of that. Okay, we're going to do 22 exposures and then save it. Look at this beautiful nebula. Oh boy. Okay, so we're at 22, so now we can save it. All right, within 30 seconds or so, this will be up on the website, on our server. You can get to it by going to skytourlive.org right there. skytourlive.com will get you there too. And you can scroll down to the Take Me to Cool Pictures, and you'll get these really cool pictures. This one in particular. So if we click on this, all right, this is the picture you're actually going to get up there. This is the picture itself, right? And you can do things like, zoom in on the picture and see all the interior detail, like we've done before, like that. Very nice. Our next camera that we're going to replace the current camera with is actually going to show us the detail of this object even more than what we're seeing now. It's going to be far more detailed, and I gotta tell you, I can't wait for that. So, all right, it's a shame to clear it, but I'm going to clear it because we're going to move on, and I already did save it. So we're going to take care of that. We're going to go to our 1 second night vision exposure, or night vision mode as I call it. There it is. And that's at 75%, not even 100%. And now what we'll do is go to 33% on the size, which gives us about the right size for everything. And let's continue roaming through Cygnus. Let's go down a little further. All right. And take up residence here. This is the most beautiful double star in the sky. And it might not even be a double star. It might just be a star that's a line of sight thing. Because we see that too. But here they come. These stars that we're looking at right there, and we'll zoom in on those because we can. Those stars are beautiful. One is a blue B8, as in boy, B8 star. That is a star that is not an O, which is the hottest and bluest, but next down, B. And it's the 8th grade from 0 to 9. And then the next one's like a K3 orange star. And they make a beautiful pair of stars in the night sky. We're going to go to 100% here. Okay. And you can see the colors here even in the night vision mode. But I'm going to show you what it really looks like. So gotta wait here. There we go. Okay. All right. So now we're just gonna do a quick shot here. All right, this is going to be a 5-second shot. Not long, but that's all we need. Because look at those colors. All right, and we'll do a live stack here. And do processing. And processing. As you can see, 5 seconds is even too long. Oh, actually, no, it's not. I'm going to drop this down to 0 and clear it again. I'm dropping down the sensitivity. There we go. Look how beautiful those stars are. Aren't those beautiful? Yeah, it's just beautiful. And we'll just move things over here. Okay, let's color correct. And get rid of the green cast. Alright, and now we're going to take down the background just to show you the colors. That's too much, sorry. And now we'll take down this. Okay, look at that. Beautiful blue star and an orange star side by side in the sky. This actually makes up the swan's eye. It's in the head of the swan. So if we come back to our planetarium program here and we look at this and hit the mythology, there's the swan's eye right there. Okay. Interesting. This is the eye right here. It's kind of hidden. Cool stuff. Yep. Yeah. All right, so we'll call this Alberio, and we'll actually save that after we have a few. Oops, I spelled it wrong. Okay. All right, and we're going to increase the gain a little bit. And clear this again. And do this over. All right. Very beautiful star. I'm going to just do one more thing here. This is too long. It's even too long. I'm going to do 2 seconds now. Clear it. And start again. Clear it and start again. As you can see, even... Oh, it stayed 5 seconds. Sorry. I wasn't supposed to. Alright, here we go. Here we go. That's better. Isn't that beautiful? Beautiful colors. Night sky. And by the way, one thing. Oh, hi, Gladys. Gladys here. Yeah, she says you haven't streamed in 2 weeks. I know, because I was in New Mexico. I went to the Very Large Array. I did talks in Roswell and Tucson. And I may be going to South Texas next month to do a talk as well at the Edinburgh UFO Festival. That's still possibility. That is stunning. Oh yeah, Alberio never disappoints. Okay, we're gonna just go to 20 of these just to have enough, and then we'll save it. Here it is. That's how quick they occur. All right, we'll save exactly as seen. All right. Now we can get out of it and come back to our 1 seconds. But there it is now in just our 2 second shot. And let's see it in the 1 second shot now. And there you go. Now if we do our night vision mode there, you can see. Pretty cool. Alright, so now let's go back down to our 33% size so you can see what it really looks like in our system. That's 25%, you mean that. Okay. There we go. Okay, now back in our system here. We're gonna go now to one more thing, which is now probably up. We saw the Ring Nebula, and now we'll see the Dumbbell Nebula. The Dumbbell Nebula is also a planetary nebula, just like the Ring, formed in much the same way, but the Dumbbell Nebula has a different set of characteristics than the Ring. There it is. And you can almost see immediately what it has going on. It's actually called a bipolar nebula. Now that means that it actually has two lobes that are coming off in one particular pair of directions, up the top and down the bottom, and not so much here. What's that mean? It means that this is probably like north and south, and that this is a rapid rotating star that was sending material off along its equator, and it made a longer set of material coming off here. But that's not exactly how it looks when we actually do the imagery. Let's do a 12-second shot of this, because that's really all we need for this. Okay, let's get out of night vision mode, go into our live stack and remove Alberio. Get one more look at it there. Say goodnight to Alberio. Clear it, and then the dumbbell comes in. There it is. And we're going to zoom in, and you're going to watch the image will clear up immensely with the second shot. Okay, watch this now. Are you ready? Here's two, and boom, you start to see more detail. This is only 150 gain. We're not even at the high gain mark now. Cindy, I saw that you got the Casper on a notebook, the horse head in a duffel bag, and a Christmas tree blanket. I saw that. And I checked the order, and two of them are done and ready for shipment. And I think the journal, the notebook, is the thing that's last on the list. So they're all going to go out together, I suspect. Look at that. Okay. Now let's talk about what you're seeing here, because this is kind of important. This is, of course, the Dumbbell Nebula, and of course, it's named for the fact that it looks like a dumbbell. And this is a planetary nebula as well. It's called a planetary nebula because planetary nebulae in small telescopes look like faint planets. That's how they were named. Kind of a sort of a misnomer, because they're not really planets, but that's what they were called, right? So this is the Dumbbell Nebula right there, and if you notice, you have this star right here in the middle. Okay, that star that you're seeing, all right, in the middle right there, that star is actually another white dwarf. All right, so our white dwarf is right here in the middle. It's blue, and it's actually the guiding force, the illuminator, the power supply for lighting up all of this material here. Now, in this particular nebula, you notice it seems to have a sharp division here, a sharp division here, some strange features here and there, but then more diffuse stuff on the outside. So this nebula is not done expanding. There's still stuff going on, you know, which is really interesting. So let's go back now and see if we can add some details. Okay, we've got 14 stacked already. That's good. All right, let's darken up the space around the star. Okay. Look at that. Hey, Lubo. How are you doing? Oh, that's fantastic. Lubo's talking about doing a narrowband shot of the Dumbbell Nebula in China. Very cool. Yeah. So, you look here and you see there's additional green ionized oxygen out here, doubly ionized. And it stands to reason, by the way, that we're going to see oxygen and hydrogen in a lot of these stars. Why? Well, I've mentioned it before, and some of you may be thinking it, and if you are, my hat is off to you. And that's because hydrogen is the single most abundant element in the universe. Okay? So it stands to reason we'll see a lot of hydrogen in stellar remnants. Oxygen is the third most abundant, okay, next to helium. And oxygen makes these beautiful green colors, so naturally we'd see a lot of oxygen as well in nebulae, and we do. Orion nebulae, other emission nebulae. Not in the Gamma Cygni nebula because that's predominantly a hydrogen gas cloud. But look at that, huh? That's cool. Let's see if we can... Yeah, there we go. Got a lot of detail in there that we're pulling out. But look at that beautiful, sharp object right. That's cool. Okay, let's reduce the colors. Saturation seems a little high. And if we reduce the colors, that's probably going to do us a little better. All right. Look at that. So now you can see all this stuff out here, way out here. Very, very diffuse stuff. And to see that, we'll move this. All right. And move this over. This is the black level that I'm trying to move over here. And this is the mid level, and the white level is way over on the right. Look at all this stuff out here. Look at that. That's pretty interesting. Just gorgeous. That's pretty cool. All right, so let's let me just move this more in, just to darken the backdrop up a little bit. Neato. Okay, so if we back out a little bit, it's almost overexposed in the center, and to get rid of that, we do this. Okay, now look. And then as it sharpens up, look at that. Oh, wow, that's cool. Yeah. Gladys, have at it. I think that'd be funny. She wants to make a video of me just floating. I like it. That's really pretty. Very nice. That's our Dumbbell Nebula. I think this is the second time in the season that we're looking at it. Okay. And we'll save it. And we'll save it exactly as seen, too. There we go. Yes, Lubo. It has outside layers. Let me show you where those are. If we just pop in this other level here, you can see all these outer layers, too. Okay, this is a real punch. Those outer layers are of course there. All right, and they are in the other one here as well. And we just have to do this to kind of show them. And these are a little gentler to look at. So you can see them here. Very cool. Well, Lubo, thank you very much for coming out tonight, and we will see you next time. Next time we do this. Okay. Let's move this down a little bit. There we go. So now we can see that blue-white dwarf in there. And we're at 45 images that we stacked. That's great. We're going to leave those. And those are going up. All right. And so we'll come back. We've got the Dumbbell Nebula all set and done. And now we'll go back to our night vision mode. There it is. Come back here. And we'll continue moving through here. And as we move down, I'm not sure we'll be able to see these yet. It depends. We'll try it. Let's see if we can see. Let's see if we can see. Oh, I know, actually. This will be just an attempt. I want to see if we can spy this dark cloud here, the Milky Way. Look, it's just sort of just a random location, see? And you're thinking, well, there's not many stars there. How much you want to bet? So we're going to go there now. And we're on our way. And you watch the telescope right here. It's moving. And it's moving into the lower part of the Milky Way, down towards Sagittarius. Not there yet, but moving toward it. Shut off that because we're done. Okay. Now we'll let it do its thing here. Before we do that, I am going to refocus because I know we have to. Alright, so I'm going to take my stars out of focus and then go back into focus. Here we go. We're going to build our curve, our parabola, and it's going to move a discrete number of distances that will find the best focal point, because it'll move a discrete amount of turns, and no one of those turns will be the perfect focus point, but it's going to build an equation that it fits through that curve. All right, and at the lowest point in that curve, that's where the image is the smallest and most compact. You can see our curve is already forming over here. In particular, see it right about here. We should see a line show up right about there. Alright, okay, fair enough. Alright. There is our curve. And it might be modified slightly depending on other data, so I let it finish. And we're done. And now we'll go to best focus. You watch that change focus up there. Goes out and then in and then boom. That's the sharpest, best focus there is. I like autofocus. It's just so much fun. Alright, so we're at this random location in the Milky Way. And let's see what 30 seconds gets us here. Okay, but before we do that, we're going to take the sensitivity up to 250 again. Hop out of our night vision mode and go right into our live stack. And to remind you, the Dumbbell Nebula, which came before, isn't that stunning? That's just beautiful. Wow. Alright. So we'll clear that now. That'll be up on the server in just a few moments. And here comes the Great Rift area. Wow. So look at all this dark nebula. This is all dark nebula in here. How do we know? Well, let me show you. Look at that. This is the Milky Way. And let's look at that. Wow. So this is dark nebula. This is all the dark dust that makes up the dark lanes in our galaxy. And just a random smattering and just a random positioning can show it to you. Wow, we'll do a few of these. And I'm going to call it Great Rift Location, because it's like the Great Rift in our galaxy that we're exploring right now. Okay. Notice that there's dark nebula, there's diffuse hydrogen emission, there's nebulae. This is a small emission nebula in here. Now, if we actually go to this location on our planetarium and pop into that location right there. That's not the place I wanted to be. I went to the wrong one. Let's just back out of that and go here. And go there. Alright, so they'll go in there and then we zoom in. And you'll notice, okay, see these stars up here? These stars should be to the upper right here. And there they are. There they are. And there they are. So that's really pretty. That's making a tremendous, makes a tremendous impression on people when they look at the relatively empty sky and notice that it's full of stars and nebula. But I wanted to show you what it looks like in like one particular region like that, because that way you have an appreciation for the random sky. A random location can look just so stunning. Look at that. Wow. Let's see if I can darken up the background just a little. And add. Okay, just bring out some more detail. All right, now let's do this. Look how dark that dark nebula is over there. Look at that. So stunning. And the more you stack here, we've only got 8 stacked right now, but the more you stack, the more they start to look three-dimensional. You start to see what looks like depth. Now, admittedly, much of that is an illusion because we don't know offhand how far away all these things are just by doing what we're doing. There are catalogs of the galaxy which show distances to various objects that we're seeing here. And I'm sure we could get that information. But it's just so much fun to see this for ourselves and just explore it. Beautiful red star there. It might be a red giant. Or even a red supergiant. Actually, we might know. We might know the answer to that. That's the star there. It is a giant. It is an M2 giant. So this star that you're seeing right there, which is that star, is an M2 giant, which means that it's the stellar classifications go O, B, A, F, G, K, M, as in Mike. And the M stars, those colors are defined by temperature. So M stars can be small, tiny stars that are only slightly bigger than Jupiter, or they can be the most massive stars in the universe because their outer layers are only about 2,500 Kelvin or 3,500 Kelvin in temperature. So, neato. Okay, we did a dozen here. So we're going to save the Great Rift location here. It's just a fun location to hang out. And we'll save it exactly as seen. And we did. And we'll clear it now. Get rid of our stack. Go back to our night vision mode. There we go. See what's hiding behind there? And then back here, let's see if we left enough time or waited enough time. All right, we're going to go down here now. Let's see. What do we got? Oh, I think we might be able to see it. So we're going to go check out the Eagle Nebula. Hopefully we can see the Eagle Nebula. It's not lost in our wall. But it looks like it might be just fine. So here we go. Yeah, we're going to see it. We're going to be able to see it. Yay, yay. There's the Eagle Nebula. You might recognize the Eagle Nebula from the famous Hubble photo, The Pillars of Creation. And that's what this is. These are the pillars of creation, but where are they? They're right there. I'll point them out. Don't worry. All right, so we're going to move over now. Okay. Okay, now we're going to drop down, bring it up. Okay. There we go. All right. Let's zoom in on this right away. By the way, this image is going to take up a good portion of the screen. There's a lot of stuff going on in here. An awful lot. Let's zoom in enough so you can see the pillars of creation. Do you see them? There they are. One there, one there, one there. Okay. And now what we'll do is we will take a photograph at 250. Actually, I'm going to go to 200. We'll do it at 200 sensitivity. And we'll take this picture for 25 seconds. And you might ask, well, what do you determine that? How do you determine all that? It comes down to experience. As you'll see, this will work very well. You'll be able to see the pillars of creation quite well at this setting. If we just really did a massive long exposure, they get blown away by the brightness in the middle of the nebula. So, let's check it out. We have 3 seconds to wait. 2, 1, 0. Bam. Let's see it. Doesn't look like much, does it? Well, that's because we have to shut off our night vision mode, and then we have to adjust our settings. And there's the pillars. Okay. We have to color correct. Look at that. Look at those pillars right there. Incredible. All right. And as I said, it takes up most of what we see in this image. So this goes all the way out. Goes all the way out. See that? And now we have 3 images stacked, and you'll notice how much better it looks. So the other thing is, this is called the Eagle Nebula, and the pillars of creation are a feature within it. Okay. So basically, it is that. Eagle Nebula with pillars of creation. Stunning and just stunning. Lots of dark nebula in here. These are all molecules. Molecules of carbon. Lots and lots of carbon aggregated together. Silica compounds aggregated together. And then with liberal coatings of ice on them all. The foundational materials from which life is made. Look at that beautiful nebula. Wow. Gladys says she can see the nebula or the eagle now. Ray, the Booty's Super Void is up, but it's not interesting showing just a screen with just a few stars in it. I thought of that. I actually went there earlier tonight to shoot a flat field. Isn't this nice? So what do you think, guys? Is this worth it or what? Let's zoom in on the actual pillars. Look at that. There's one pillar right there. There's a second pillar right there. Another little pillar right there. Little objects out here. You can see them almost as 3D objects. Well, I'm glad you guys like it. Let's zoom out all the way so you can see what the full frame looks like here. Okay, so there's the full frame right there. Let's see how much else is in here. Here we go. We're going to just do a blast right here to show you how much else is in there. Look at that. That's why I said it goes to the whole frame. It's all throughout here. Oh, Anthony, thank you. Says made his night. Thank you. It's really cool. Hey, you know, I mean, this is why I wanted to be an astronomer, because this right here, you can't get this unless you make an actual effort to show it. Very cool. Okay, we've done 12 images here. We'll do a couple more, and I think we'll move on. So we're just going down the Milky Way from Cygnus to Swan up there, down the Milky Way. Actually, in the view there, you see it, Cygnus to Swan is up there, and we're going down the Milky Way to the south. And I'm hearing a vicious thunderstorm outside. So if we lose power, I apologize ahead of time. So actually what I need to do is take into account that may happen. Eagle Nebula, Pillars of Creation, in case you want to know where they are. I'm going to save them right now. And save them just as seen. Awesome, we're safe. Okay, so what's happening right now is these are being saved on the observatory system and being shipped out of the observatory system up to the cloud, where they go down to our server at skytourlive.org, which you have free access to. And you can go in and look at these images so you see just like you see it right here. All right. In fact, here is the Eagle Nebula as it's going to be out there right now. There it is. So that's what's out there now. It's gorgeous. Holy cow. Oof. All right. Okay, so let's clear this right now, because we're going to head to another object. Indeed we are. Okay, so that'll be up there in just a couple seconds. And let's go back to our night vision mode so we see where we're going. Here we go. And then there it is. You see the nebula there with its stuff. And now we're going to actually see if we can take ourselves down here. I want to show you this guy. Not sure we'll be able to see it yet, but I'm thinking that we should. Based on where things are looking, I think we can do it. Yeah, we can do it. Oh, look at that. Oh, you're going to like this. You will like this. I promise. All right, we're going to move this over. This is a region of space where there's a young hot cluster of stars. And this is in our Milky Way. And this region is punctuated by this nebula and that little object right there. That object you see right in there, that's actually an O star in here, the hottest, bluest star ever. They only live a few million years, and then they go supernova. And that's what's going to happen in here at some point. Dingo, come here. My little dingo is here because she's afraid of the thunderstorm. So she came all the way downstairs from 2 floors up. Good girl. You lay down. It's okay. This is the Lagoon Nebula. It's really pretty. I'm going to move us east just another notch, because the lagoon is not the only thing here to see. And we're going to see another really cool thing up here. And this is just about right. There's so much going on here that you cannot help but see more stuff going on all throughout the frame. So let's just one more little jog just to get it all, because I know what's over there. Shh, don't tell anybody. Okay. And we're gonna wait for our guide star. Now what's interesting is over here on the left there's another nebula, okay, and that nebula over on this side is called the Chinese Dragon Nebula, and it's actually pretty cool. I think I'm gonna have to go just a little more north though. Here we go. Okay. This should get us what we want right there. Okay. I think we're good now. So we're going to get our guide going, and once we have our guide going, we're going to be all set. So long, Mr. Django. Thank you for coming. Okay. We're guiding. We're stable guiding. Now, let's do the shot of the century, guys. Let's do a 35-second shot of this nebula at 250. Okay. And off we go. Let's leave night vision mode and go into our stack. I hope you guys are prepared for this. This is really gonna knock your socks off. Anthony DeSanto, that's actually quite clever. 'Cause like I said before, it's been a Dances with Nebulas night. That's true. And in just 1 second here, you're going to see a new set of nebulas. Watch this. Oh! Now, you talk about nebulae. Let me show you the full extent, okay? Here we go. Let's go to here. Oh, I just missed it. Darn it all. I got to go over more. But I will momentarily. Check it out. Boom. Wow. Now talk about a nebula. And you're going to say, what are you doing? You're killing it? Yes, I'm moving over more. Because I want you to see the whole thing. Right? So I'm going to just pop into night vision mode for just a second. And I'm going to move this over here a little more. Right, here we go. Now let's just go to the east a little more. Okay. So what we want to see is right here. And right here. Alright, this is good. And now you're going to see And by the way, the nebula that's over here, growing up doing amateur astronomy when I was younger, and before I ended up doing professional astronomy, I actually looked at this nebula many, many times, and I never saw the nebula that was over here. As you can see, this one's much brighter than this one. There's that hot O star here in this little hourglass shaped feature, which is actually like causing this whole nebula to glow. And it's got all kinds of veins of beautiful dark nebula, which you're going to see. So let's go back to a 35-second photo. Wow, it just looks stunning. I was so amazed with it. At 250. Okay, guys, here we go again. And now it's going to be very different. But here's the previous image, or did I clear it already? No, I didn't. But now it's going to be better placed. Wow. Look how red that is. And we'll do that one full screen too, by the way. Okay. 5 seconds. 2, 1, 0. Wow. Look at that. So this is called the Lagoon. And that's called the Chinese dragon. That is just outrageous. And that's only one. The second one's going to make it look even better. And that's in 2 seconds. Here it comes. Look at that. That clarity immediately shows you this beautiful sinuous black dust lane. Let's go see it. Look at that. Snaking through here. That's incredible. This is a bluish reflection nebula. The star's light is hitting the dust. And the dust that's in this nebula, all the black stuff that's currently illuminated, this blue area is actually this dark stuff, but only when a star can illuminate it. And when the star illuminates it, the dust is very good at scattering only the blue light, the higher energy light, because the dust grains are a certain size, and they really, really enjoy the short wavelength light that's blue. And so we see blue nebulae in the universe. The Pleiades, for instance, has blue nebula all around them. And it's not because the stars are blue per se, it's because of the fact that the blue light coming from the stars is being scattered, and it makes this blue color coming from that part of the sky. Well, let's go back to the lagoon. Look at this. Isn't that crazy? And look, this is all blown out. You have to pick and choose, what you want to do. So if I come over here and I take this and I slide it over, okay, you can see that we can get down to a certain depth. See that? Really pretty. So we can actually just go back to our primary adjustment there. Right, and let's do what I promised we would do. First of all, let's get rid of our stack. Okay. And then let's actually get rid of our telescope and maximize this. Look at that. Now we'll see this. This is cool. That's an amazing photo. And again, this is the Lagoon. And Chinese Dragon Nebulae. Move this up a little bit so that and not all there is. There's a lot more here going on, but you can see how they're connected. Isn't that cool? Cosmic ray speaks truly. There are what are called Bach globules in here. I will show you a few. And what are they? They are regions where this dust has gravitationally contracted into a ball of ever-increasing mass, and as it contracts into a ball of increasing mass, it's also got gas in there, hydrogen gas, and so we might see the birth of a star in there, and a star system of planets made from that dust, which, by the way, doesn't just contain carbon and silicon. It contains phosphorus, potassium, calcium, all the stuff that was made in the heart of a star. Like you, everything inside of you was made in the heart of a star. Notice how the image is getting better and sharper and clearer? That's because we're stacking. The more we stack, the clearer it gets. Ah, beautiful. What a gorgeous night this has been, guys. What a gorgeous night. Very, very impressed with all this. So we traveled from the Milky Way, from Gamma Cygni all the way down. And so I thought that was pretty cool. Now let's see. We've got 9 stacked so far. That gives us enough to zoom in now. Let's zoom in. So here in the Lagoon Nebula, you see all these dust lanes. Sinuous stuff moving through there. And the result of countless shock waves from stars that have gone supernova in the past, making those sinuous shock waves that you see. And the Chinese dragon has got some really interesting nuances. Like, look up here. Look at this subtle texture. All right, let's just zoom in a little. We have dark material, and then it kind of gets fuzzy at the edges because it's starting to move out to be thinner, and you also see that starlight is illuminating it directly. And that makes it look like it does. And then here in the Chinese dragon, here you see this sinuous little, well, I'm not sure if this is the dragon itself. It looks like a dragon's head with a body. Okay. But I'm not sure how that reads. But this is something. It's really beautiful. Very nice. That's beautiful. Okay, let's bring our stack back and dock it there. And then let's bring back the telescope. Okay, there it is. Beautiful. Okay, we're going to stack to 14 here. There we go, and then we can pause and save it. There we are. Saved as Lagoon. Save exactly a scene. There we go. Nice. Okay, and now one more object that I want to show you, and we're gonna just go back to our night vision mode. Before I do that, I want to show you what's inside here. you can see this little hourglass shape right there. There's an O star in here that's causing that to be really, really excited. That's what powers this whole nebula, is that one O star. And this is a young hot cluster up there. Which may also have something to do with it. Okay. Let's go back here now and go right back up the Milky Way now. So I think this will be visible now. This will be a cool object if we can see it. I think we can actually. So you watch the telescope is going to go shifting all the way back up to the north. There we go. TD. Yeah, you'll notice this is good position too. You'll see that there's something here that looks like it's reddish. You know, and that there is actually. And we're actually going to move a little bit west right now and south. We're going to move south first. There we go. Then we're going to move west. Because I know where I'm looking. All right. And right here should be good. Yeah, this will be good. Okay. So this is, you can roughly see it now. This is the North America Nebula. Looks like North America. There's Florida. Here is Mexico. And you'll see a really interesting feature here. I'm going to just drop us down just a little more. Because there's an extra feature down here that you don't see unless you go do that. All right. Okay. Waiting for a response. Okay, it's responding now. That's good, and I want to go just a bit south. Okay. So this is a very nice feature right in here to see. Okay. So we'll let this stabilize. We'll get our guide star, and then we're going to do a 35-second shot. And you're going to like this. See what's hidden in here. Okay. Off we go. And as a reminder, we came from this. Lagoon Nebula and the Chinese Dragon. I hope you guys enjoyed that. It's up on the server now. Yeah, Ray points out a very important fact, which I'll get to in a sec. All right, so here it comes. Wait, you'll say, where is it? What am I looking at? Well, we have to just do some processing first. Ooh, wow. Look at that. This is the lower part of the North American Nebula and the lower part of the Pelican Nebula here. I am going to kill it and do it again and move us down. Go a little bit north. I dropped a little too far. I mean, it's perfect to do mosaics as well. Here we go. This part right here is called the Cygnus Wall. You'll see, hey, Starlink, wait for me, wait for me, wait for me. Oh, another one going the other way. That's cool. This is the eye of the Pelican. The Pelican's sitting here, looking this way. You'll see. Okay, we are guiding now. 35 seconds. Off and running. Alright, Captain. We're taking our exposures now. Excellent, Scotty. So this has been moved south now. So much to see in there, as you'll see. I'm going to guess Daryl lost power because he never even came back into the chat and did not answer the phone when I called. Oh, look at that. And let's just zoom out a little bit. So what you're seeing, okay, that's the Pelican. And you can see the beak, if you think of it that way. And, of course, the North American Nebula. And this is only one exposure. When we get two, you'll see how this begins to differentiate and look less muddy. So we have 5 seconds coming up here. And look at that. Just an immediate increase in sharpness. What a beautiful nebula. Beautiful, beautiful. Beautiful, beautiful. Wow. So you can see all the complexity going on over here. Look at all this stuff going on. Okay. This is, again, the Cygnus Wall, an area where gas and dust are hitting a wall, effectively, of interstellar material here. Look at all these deeply rich convolutions of material, little tendrils of material that are happening in here. And with each successive stack overlay, we're getting even more detail. Very nice. Wow. Only 4 stacks so far. Let's see if we can give us a little more contrast, but sure we can. Okay. Zoom out. See that? What a difference, huh? Just crazy. and this is the North American Nebula. I didn't see Daryl come back into the chat. If anyone saw him, let me know, because I didn't. Vincent Gilio, thank you for coming out, hanging with us. Hope you have a good night. This is our last object for tonight. Let's zoom in over here on this beautiful area over here. Look at the detail in here, guys. Look at the detail. Wow. These beautiful soft swoops of black material. Look how detailed it is too. All these little tiny edges, pieces, tendrils, little tentacles, complex cloud structures, all suspended in space and all moving. It's all moving. It's not just sitting there. It's moving, propelled by the stellar winds of nearby stars. Gladys S. Are there other nebulae that have continent shapes? I have to look and see. I'd have to look and see. This is all diffuse hydrogen gas in here, and this stuff here, this black, those aren't voids. Those aren't voids. That's actually stuff up here blocking what's behind it. It's actually gas, or dust rather, blocking the bright nebula behind it. So if you can see that, which you can if we like zoom in on this. So you can see how this is dust that's blocking what's behind it. Right? And that's what we got going on here. How cool is that? Okay. Beautiful, beautiful, beautiful. Well, this is the first night we've been able to image the North American Nebula. Go a couple more here. Lyrae. And we're going to talk about Pelicanidae now. The pelican bird, which is right here. Obviously, it's not a pelican, obviously, but it is, looks like one, just like this looks like the United States or North America. JSCO, I'm so glad you came on tonight. I was getting withdrawals. Me too. Me too. Looks like a map with Europe on the right, Anthony says. That's cool. Yes, Dingo is now sleeping at my feet. She's afraid of thunderstorms. She was a rescued dog from a drug bust. Yeah, we got her because the cop called and said, "You want to take her?" Friend of ours. I said, "Let me meet her." I met her and she started playing with my black lab. That's a lab shepherd pit bull mix, who has passed away in the last couple of years, and the two of them got along so well that I said, "This dog is not going anywhere. This dog is now part of this family." And she did stay. And Indy, the lab, died a few years ago, and Dingo is still kicking. Every now and then she does things that lets me think that maybe she misses Indy, but I can't tell. Okay, there's our 17th exposure. North American Nebula is labeled, so I'm going to say save. Save exactly as seen. And there we go. What a night, guys. I think this was really, really a good night for us. We had a wonderful set of objects to see, and we traveled right through the Cygnus Milky Way down into Sagittarius to see some really cool stuff. So I hope you guys had a good time. I will find out about Daryl tomorrow. Like I said, I heard him trying to talk, but I couldn't hear. He couldn't hear me, but I could hear him. And he was saying, "What's going on?" And I think his machine was in the process of dying. Anyway, I hope you guys have a good night. And I'm looking forward to doing this again with you next time. It's been too long. So have a good night, folks. And I will see you on the other side. Good night, everybody.